So I'm going to be talking about input sanitization, as I think Christina just said. I wasn't listening. This is probably one of the most important things you can do when building a web app. I mean, besides actually making a web app. It is, as it says on the slide, the only thing between your web app and certain death. So the first big idea behind input sanitization is that you don't want to run code that you didn't intend to. If you have some code that does some things and some code that does some other things, and some things are supposed to happen, you want that to happen that way, right? That's pretty intuitive. And the other big idea is you don't want to write code that you didn't write, or run code that you didn't write. That would be extra bad. And that is really easy to do if you don't sanitize your inputs, which I'll get into in a second. But first, we're going to talk about HTTP. So HTTP has two types of requests. The first, well, it has 10 types of requests, but the two important ones are GET and POST. The first one, GET, you have parameters that are passed as part of the URL. So you can see after the question mark, there's the Q parameter, and its value is Django. This is how a URL for searching on Google would look. On their search page, you pass in Q, and that's what you're searching for. Right? And then there's some other shit that's not important. But for a post, the parameter is not in the URL, and it has some additional things that are not quite so important. And then in the body of the request is the actual parameters. So the distinction is mostly irrelevant for us right now. It's just that there are two types. POST is usually used to change things. GET is used pretty exclusively for getting things. So a search would be a GET, whereas buying something would be a POST, or logging in. So let's do some example code. This is part of a Django application, an extremely boring one. It takes one parameter, the N parameter, and it adds one to it. And there's no input validation here. So this is going to be the most simple type of failure for an input validation type problem, is that it will cause the application to crash. So if we just use this, if we just go to use this application normally, and we put in a nice parameter like 5, then it gives us 6. I don't know if you can see that. It's cut off on the projector. That's annoying. Anyway, can everyone see that that's a 6? My program successfully adds 1 to another number. OK, but if I take off this n equals stuff and just go for the web page, I get this big ass error, and all this stuff is wrong. We don't want this. So what we want to do instead is we want to validate the input. So this gets the n key from the request, and if it isn't there, it substitutes that value with none. And then if the value is none, then it returns a response that says, you are bad, you didn't give the right input. And then only once the input has been validated, it actually performs the addition, which is tedious, but it works. So if we take off this parameter up here, then it validates our input. But of course, there's a problem here still that I'm not going to address, is that what if you don't put in a number? Right? It does a Google search.
Because it interprets spaces as...
Probably it triggers a search. But yeah, another problem. It tries to convert that to an integer because my code is bad, and it doesn't work. So input validation is non-trivial because there are going to be more and more problems every time. And I'll get into how to fix that. But first, we're going to talk about code injection, which is the worst case. If your application just crashes, that's kind of OK. It's bad for your user. It makes you look dumb. But fundamentally, nothing terrible is happening. Code injection is when somebody else puts input into your application that then gets run as code somewhere else. And there are three main types of code injection. HTML code injection, which can change the change how a page looks depending on where the HTML gets injected. Then there's JavaScript injection, which can cause arbitrary code to be run on other people's computers. And then there's SQL injection, which can cause arbitrary code to be run in your database. None of which are good. And then, there might be other code in your application that can be injected, and who knows. A lot of applications run different types of code, or maybe even scripting languages inside the application. At Amazon, we would actually run Lua and JavaScript in the back end. So potentially those languages could be injected as well. So HTML injection is pretty simple. It's also pretty benign. Users submit HTML to your site instead of what they're supposed to submit. And then that HTML is displayed to other users. And then because of that, that HTML is interpreted by the other users' web browsers. And, that sucks. So I have another dummy example app. I made a Twitter application, sort of. So I can tweet something, and then it goes on, everybody's Twitter wall. And I can put in HTML to do something relatively benign. I can change the color of the text to be red. And that's fine. Or I can just, or I can do a lot more malicious things. I can say style display. So what I've done here is I've entered HTML. This is the start of a block that is going to not be displayed, and then I don't close it. So then any future tweets are going to be captured in that block and not displayed. And we can actually look in the source code that we're getting back from the server, and we can see, okay, here's this div, and all of the tweets have sort of been shoved in here because of this HTML injection. And they're there, but they're just hidden because we've used HTML to change what the page looks like. And you can protect against this because you can actually escape these things so that they don't get interpreted as HTML, which is my next slide. No, it's not. Okay, so you kind of have two strategies here. You can either just not allow users to submit HTML. If you see HTML, then you can say bad. Or you can sanitize the user data during output by escaping things. So HTML only has 3 characters that have special meaning. That's less than, greater than, and ampersand. And if you replace all of those with these escaped versions, then it looks like this web page instead. And so that's, you can see in the source code, if we look, it has, the framework I'm using has replaced all of the stuff in here with these escapes, right? So everything is safe. And the worst version of this is script injection, also known as cross-site scripting. And that's also done through HTML injection. So you submit HTML that has JavaScript in it to the site, and then users see this, and the JavaScript is run by their web browsers, which is really, really bad. Running arbitrary code on other people's computers is like what every malware author loves to do, and you just let them do it. So an example of how this could be bad, assuming Facebook didn't sanitize its input, but they do, you update your status containing a script tag, and then you do whatever you want, like post statuses as other people or like pages, and that would not be good. There were a lot of things going around Facebook a few years ago, back when Facebook still had these problems, where you would click on something and then it would post a status on your wall because of cross-site scripting. A worse example is a bank. So your script might create fraudulent charges, or send your data to a malicious target. So if the script can read the page that you're on, because for some reason this script is running, then it can see all of the stuff that is on the page you're viewing, and it can make requests over the network to another website and send out things that you don't want, including user sessions, which is extra bad, but not terrible if you manage your user sessions properly, which we'll talk about later in the quarter. So yeah, script tags are how you inject JavaScript. It's actually just HTML injection, except you include scripts. So if you do this, then you're pretty much fine, because script tags are just HTML injection, or just HTML. So XSS, script injection is really just HTML injection. So I have an example of that too. Over here, if we are, injecting, so we have the script tag and then some JavaScript that is going to go over all of the tags and change the text content to butts. So didn't work because I didn't debug my code. There we go. So now it doesn't matter what somebody else tweets. It's just going to say butts. And also, because of that earlier problem with the HTML div that's displaying none, still no new posts are going to show up. So if we go back to the safe one, which escapes the HTML, we can see this post, and it's been escaped, and it's not being interpreted by the browser because it has those little escape characters, right? So that's one of the big things that you can do, and that's something that you shouldn't have to do yourself. It's covered by most web frameworks. They will have facilities for escaping user data, like Django has the safe tag, and then also just auto escapes everything by default. And Ruby on Rails does this as well. Why am I on this slide again? But the worst thing that you can possibly have on your website is SQL injection. So SQL is the structured query language. It's used for querying databases. And it looks kind of like this. You say, give me these things that I want from my database. And then you can match about different types of things. And SQL injection is really only caused by negligence. It should be dead by now, but it isn't. People keep doing it over and over again because apparently not everyone learns how not to do SQL injection. So, like I said, you can run arbitrary code in the database, like getting unauthorized data. Like normally you're the application presumably validates what you get out of the database and says, can this user access this data? If yes, give it to them. If no, no. But with an SQL injection attack, you could potentially dump all of the users in the database and their passwords. We'll talk later about securing passwords to make that not as big of a problem. They can also change things in the database, which would not be good. And they could just delete everything in the database. I wonder if anyone has seen this. Probably most of you have. But in this comic, the mom executes a SQL injection attack against the school and causes them to drop their database of students. You can see in the third panel, the son's name is Robert, quote, paren, semicolon, drop table students. And then that dash dash at the end is a comment to nullify everything else that comes after the SQL where it's injected. And yeah, that would be bad. They presumably need that data. So mitigating this, you use prepared statements. Seriously, it's really easy. We'll take a look at an example here in PHP because everyone loves PHP. Okay, so this is an example of something that's vulnerable to SQL injection. So this is presumably a login page where somebody has posted their username and password to log in. And we're creating a SQL query, select password from users where username equals, and then PHP lets you embed variables in strings to substitute them in. So, if this user was, Robert, drop table users, then, okay, I'm just gonna disable this quote for now. Then it's going to actually put this in the query. It's going to change the actual SQL that's being executed, right? And then that's going to cause bad things to happen in the database. So this PHP actually has another problem in it, which I'll go over next. But the way you do a prepared statement is just about every single database client on the entire planet will let you do something, have a prepare function where you put in the query that you want to execute. And instead of putting in the stuff yourself, you put in a little placeholder like a question mark or sometimes a name or, yeah? Question? Maybe just raising your hand? No? Okay. A placeholder like a question mark or something else. And then separately execute the statement with the parameters. And then it will escape everything itself. It'll make it all safe and clean to do. And usually it will do something special in the database driver to make it faster too. So there's no reason not to do this. You always want to use prepared statements. It's a little bit more tedious, but it's really worth it. So the next problem with this PHP code, I wonder if anyone knows this bug. It's a fun one. But the problem is with this line. This is actually in a CTF that we participated in a while ago. You do?
No, sorry, I just wanted to ask a question about this.
Yeah.
So if this is basically almost universally necessary,
Mm-hmm.
why has it not been made easier to write? Like, if this isn't the simplest way to write the code, why haven't they made it simpler?
I mean, it pretty much is the simplest way to write the code.
Fewest characters written.
Well, there are a lot of...
Backwards compatibility.
Yeah, that backwards compatibility. It actually isn't that many more characters to write than putting the string together yourself. Putting the string together yourself is actually a pain in the ass. It's just that if you don't know about prepared statements, then you sort of think you have to do it. And that was the goal of that slide. You know about prepared statements now, so do them. There actually are a ton of libraries. We're going to be looking at one for the second part. We're doing the project that protects all interactions that you do with the database from this sort of thing, and you don't use prepared statements at all. And it just handles that nicely, along with some other input validation. So, question, or are you just fiddling? Okay, I'm fiddling. So, the bug here is another input validation problem. Can anyone tell me what the type of this variable should be? Password? String, right? You would think. Okay, but I get it from this variable here, right? So we would expect, the query string looks something like password equals, let's go with an even better password. Okay, right? You'd expect something like that, maybe username equals Bob and password equals that, right? Yeah?
Why is would there be the question mark for the post request?
You're right. There would not be. Good work. Okay, but what if some malicious user puts in this? So now the type of password is an array and not a string. And this is where it gets fun. So strcmp, if you put in a string and a string, then it returns 0 if they are equal and non-zero if they aren't. But if you put in an array and a string, it returns null for invalid inputs. But in PHP, equals is fuzzy equals. So null does equal 0 in PHP. And 0 equals null. And I'm pretty sure 0 equals the string 0. And a bunch of other stuff. So this will cause, if this is an array, because a malicious user has input 2 password fields, then this will return null, and null is equal to 0, so the user is also authorized, because they put in 2 passwords instead of 1. And it doesn't matter if the passwords are correct. strcmp just says, oh, I don't know how to handle these. Fuck this, right? Okay.
Would that
So,
probably be fixed if you use triple equals signs? Since
yeah, exactly. Literally what I was about to say. So in every other reasonable language, double equals means strict equals. 0 does not equal null. And that would be great if I were to in PHP. But in PHP, equals is fuzzy equals, and you have to use triple equals to mean I really want to be equal. So with triple equals, 0 does not equal null. And this is also true of JavaScript, which is, if you hear why people are ripping on PHP and JavaScript, is because they have things like this shit. Like, nobody wants maybe sort of equals. That's just wrong. So, and you get this great huge problem here where you have to say, okay, password, like if, is string. I don't know what the function is in PHP, but I'm going to assume it's is string, and, all this other shit. In order to validate your input, it's just this extremely tedious exercise to say, man, I wish I was using a better language, because now I'm going to check all these things that PHP doesn't, because my life is awful. And most other languages have real equality, and most other languages have, types, which would be great. Like in Java, it would be better to throw a null pointer exception or something than to just give people access to your system for no reason. So it's not ideal, but such is the life of a PHP programmer. Exclamation point. Exclamation point. So that's a big problem with PHP, and that can be mitigated by using better languages. Or, so, like, there's really, actually, I need one more bullet on this, but I'll just say it. So the main things that you need to do with your users, which you will have if you have input, because if you don't have users, then you probably don't have input. And likewise, if you don't have input, you probably don't have users. You have to assume that every single piece of user input, no matter where it comes from, can be malicious. Because the world is a big place, and there will be some douche from China who will input malicious data into your web app. And then you need to ensure that the input exactly matches what you expect. Like, we can remember back in this example code, like, we did validate the input a little bit, but then we just tried to convert this number to an int without verifying that the string is an integer. So we need to validate everything and only accept the input that we know is exactly what we want. Reminder, use prepared statements. So the way you can do this is by using libraries. Input validation is a bitch, and there are a bunch of good libraries for it. For the project, I'm going to be going over the Django form validation library, which is a really good library. It is super expressive and comes with a bunch of built-in nice things. So, but there are a bunch of other libraries, and there are a bunch of ways to do this, and manually with if statements is the worst. It's super hard to read, it's super hard to maintain, and it's super boring to write. And so, sort of lastly, is trust no one, because you can't trust your users. Like I said, there's that douche in China who is technically a user, and he will screw you over. So the last thing that I wanted to have as a bullet point on this slide, which I didn't and realized while giving this slide, is know your environment. So with PHP is a really easy language to write websites in, but then there's so many little tiny gotchas that you have to know. And so it ultimately makes PHP bad for doing real things. But there are a lot of other problems in other frameworks and languages that you should be aware of as well. And you should really try and learn your language really well, learn your framework really well, and make sure you understand what's going on under the covers. Reading source code is a great way to do that. If you're not sure how a function works, read the source. The Django docs are great about that. They actually, if you go to the Django docs, a lot of the things will just have source code next to them. So validate email. So one example is the email validator in Django. You can just Google it, and we can search for the email validator. And it's like, oh man, this is how it's validating emails. Look at this wonderful source code that we can just read. Okay. Keynote, thing. So that's all I have to say about input validation for now. And trust no one.
Thanks.